Hi everyone, this is the 25th lecture of IE 451 Engineering Economy. So today we are going to solve one more problem from the end of chapter 6, and then we're going to talk about chapter 7. Okay? So this is the last problem from the end of chapter 6. Consider the following three mutually exclusive alternatives. So there are three alternatives. For each of them, the cost, uniform annual benefits, and its useful lives are provided. So assuming that the alternatives B and C are replaced with identical units at the end of their useful lives and an 8% of interest rate, which alternative should be selected? Use an annual cash flow analysis in working this problem. Okay, so I believe this problem is similar to what is this? I think this problem is very similar to 6-51 that we have solved last time. So if you look at our text page number 200, it describes how to deal with equivalent uniform annual cost for an infinite analysis period. Okay? And so we are dealing with problem number 6-55. It's talking about infinite analysis period. Okay, in our text page number 200. Okay, so according to our text, if the analysis period goes to plus infinity, then we have A equals P times I. So A given P, I% over infinite analysis period equals I. Okay? So for alternative A, equivalent uniform annual worth can be obtained by equivalent uniform annual benefit minus equivalent uniform annual cost. So here equivalent annual benefit is given as $10, and equivalent uniform annual cost, we need to consider this $100, right? And multiply by A given P and 8% of interest rate over infinite analysis period. And we use this property. So this becomes 0.08. Is that right? So this is 10 minus 100 times 0.08. 10 minus 8 becomes 2. Okay? So the equivalent uniform annual worth for alternative A would be $2. What about alternative B? Alternative B, equivalent uniform annual worth is equal to equivalent uniform annual benefit minus equivalent uniform annual cost. So here, $17.62 is the uniform annual benefit for alternative B, and the cost, $150, should be converted to equivalent uniform annual cost. So you need to multiply by A given P, 8% over 20 years. Okay? So we are looking at 8% of interest table, which is provided in page number 611 of our text. So A given P over 20 periods is 0.1019. 0.1019. Okay? So this is 17.62 minus 150 times 0.1019. So how much is this? Okay, so this value is $2.34, which is a little larger, higher than the one in alternative A. Okay. What about alternative C? Likewise, equivalent uniform annual worth can be computed by equivalent uniform annual benefit minus equivalent uniform annual cost. Equivalent uniform annual benefit is $55.48. And you need to convert $200 to equivalent uniform annual cost. So you need to multiply by A given P, same interest rate, 8%, over its useful life of 5 years. And the table value of this is 0.2505. 0.2505. So how much is this? Okay, so this is $5.38. That provides the highest number among these three alternatives, which means that you need to choose alternative C. Okay? That's the problem 6-55. Okay, now let's talk about Chapter 7, which is about rate of return analysis. Okay? So in this Chapter 7, we are going to understand and calculate internal rate of return and the incremental rate of return analysis. We will also apply rate of return analysis in the decision-making process. The rate of return analysis is the most frequently used exact analysis techniques in industry. And this measure is commonly preferred for evaluation of loans and financings for presentation to the top management level. And a project rate of return, or more accurately called internal rate of return, is the interest rate that makes both present worth and equivalent uniform annual worth equals 0. Other definition of the internal rate of return is based on the unpaid balance of a loan. So the internal rate of return is defined as the interest rate at which the present worth interest rate paid on the unpaid balance of a loan, such that the payment schedule makes the unpaid loan balance equal to 0 when the final payment is made. And for an investment, the internal rate of return is the interest rate earned on the unrecovered investment, such that the payment schedule makes the unrecovered investment equal to 0 at the end of the investment life. But the fundamental concept of the internal rate of return is the interest rate at which the benefits are equal to the cost, or the present worth is 0. Okay? So I just say internal rate of return, and IRR is the abbreviation of it. So the fundamental concept, basic concept of the internal rate of return is the interest rate at which the benefits are equivalent to cost, or the present worth is equal to 0. Okay? And in order to compute a rate of return, we must convert various consequences of investment into a cash flow, and then use one of the following equations to find the unknown values of the internal rate of return. Okay? So there are 5 different formulas that you can use. First is present worth of benefit minus present worth of cost is equal to 0. Second, present worth of benefits over present worth of cost equal to 1. And the third one is net present worth is equal to 0. And then equivalent uniform annual worth is equal to equivalent uniform annual benefit minus equivalent uniform annual cost, which becomes 0. And the last one, present worth of benefits equal to present worth of cost. Okay? Another very important thing in this chapter 7 is the discussion about the incremental analysis. So the incremental analysis is one very useful technique when there are 2 or more alternatives. And the former procedure is as follows. The cash flow of the incremental investment is computed by taking the higher initial cost alternative minus the lower initial cost alternative. And then if the incremental rate of return is greater than or equal to the MAR, which is the minimum attractive rate of return, that is the same value of I used for the present worth analysis and the annual cash flow analysis earlier. Then choose the higher cost alternative. If the incremental rate of return is less than the minimum attractive rate of return, then choose the lower cost alternative. So when you are looking at the increments of investment, we accept the increment. So when you're looking at the increments of investment, accept the increment. If incremental rate of return is greater than equals the minimum attractive rate of return. Okay. So if you are looking at the increments of investment, you need to accept the increment if this situation is satisfied. And if you consider the increments of borrowing, however, if the incremental rate of return, the incremental interest rate is less than or equal to MAR, minimum attractive rate of return, then we accept the increment. Otherwise, we will not accept the increment. Okay? Okay, now let's solve some of end of chapter 7 problems together. Sorry, but the problem description is not available right now, but I'm going to upload the class note to our class Canvas website. So you should be able to see the problem description later today. So at this time, I'm going to just read through the problem description from our text. So first, let's look at the problem 7-1. So we are required to compute the rate of return for the following cash flow to within 0.5%. So we are looking at problem 7-1. So we want to find the rate of return for the following cash flow to within 0.5%. Here's the cash flow table. For the first year, $100 need to be invested, and then for the next 10 years there is an uniform annual benefit of $27. Okay, so we just learned we can use any of these 5 formula to compute the internal rate of return, right? So let's use present worth of benefit. Maybe let's use the equation 7-1, present worth of benefit minus present worth of cost equals 0, or present worth of benefit equal to present worth of cost. Those are identical, right? Expression. So here, present worth of benefit is $27, and you need to convert this $27 to the equivalent present worth of benefit. So multiply by P given A, the rate of return, which is unknown value at this moment, over the 10 periods, equal to present worth of cost, which is $100, right? So we need to solve this equation. So here, P given A, I over 10 period is equal to 100 over 27. So how much is this? is 3.704. Okay. So now we need to look at the compound interest table of our text in Appendix C to match up this number. Okay. So P given A over 10 period .704 for the tables in Appendix C of our text does not include the interest rate that provides 3.704. So we need to use linear interpolation technique to compute the value of factor. Okay? So we need to find the two closest interest rates in order to minimize the error, okay, from the compounded interest table. So we have two interest rates which are 20% and 25%, okay, that have the values of 4.192 and 3.571 respectively. So here we need to use linear interpolation. And we want to find the value of the rate of return. Okay, so it's going to be somewhere between 20% and 25%, looks like. Okay, so let's say it's X%, somewhere between that. So if the interest rate of return is 20%, this vector value is going to be 4.192. If it is 25%, it's going to be 3.571. And we want to match this number, 3.704. Okay. Now let's sketch simple diagram based on these values. So here, the horizontal axis represents the value of rate of return, which is I. So I'm going to put 20 and 25. And somewhere between there, you have X value. And the vertical axis represents this vector value, P given A, I% over 10 periods. Okay? It's going to be 4.192, 3.704, 3.571, And we have this and this. So you need to make a connection. And then we have this. Okay. So let's say this small triangle is called A, and what you need to do is compare it with this big triangle, okay? This is called B, okay? So the height of triangle A versus base of triangle A is equal to the height of triangle B versus base of triangle B, right? So how do you compute? How do you get the height of triangle A? That is going to be 4.192 minus 3.704. 4.192 minus 3.704. That is the height of triangle A. Now, how do you get the base of triangle A? That's going to be x minus 20 versus x minus 20. And how do you get height of triangle B? 4.192 minus 3.571. 4.192 minus 3.571 versus the base of triangle B, which is 25 minus 20. Okay. So how much is this? Is 0.488 versus x minus 20 equals 0.621 versus 5, right? So the inner product equals outer product. So x minus 20 times 0.621 equals 0.488 times 5. Okay. So here x minus 20 equals 0.488 times 5 divided by 0.621. So what is the value of x? Okay, it's going to be .23929, which means 23.929%. Okay. So in this problem 7-1, we've used the internal rate of return analysis technique. So from chapter 7, we just learned internal rate of return is the interest rate that makes both present worth and equivalent uniform annual worth equals 0. That's why we've used this formula. To find the correct rate of return values. However, the tables in our text appendix C does not provide the interest rate that provides 3.704. That's why we've used linear interpolation technique to find the exact value of rate of return. And this is the correct value, right? 23%, almost 23.929%. Okay, that will be the answer. Okay, then how about next we can solve problem number 7-3. A table saw cost $175 at a local store. You may either pay cash for it or pay $35 now and $12.64 a month for the next 12 months, beginning 30 days hence. If you choose the time payment plan, what nominal annual interest rate will you be charged? Okay. So we are solving problem 7-3. Let's draw the cash flow diagram. Okay. So the first option is for you to pay $175 right now. And the second option is for you to pay $35 right now. And then for the next 12 months period, starting 30 days from now on, you need to pay $12.64 for the next 12 months. Okay? Because the internal rate of return is the interest rate that makes both present worth and the equivalent uniform annual worth equals 0. So here 175 minus $35 is equal to 12.64 cents times P given A I percent over 12 period. Okay? So here P given A I percent over 12 periods is equal to, this is 140 divided by 12.64. So how much is this? So 11.08. So let's look at the compound interest table of our text. P given A over 12 period. Do we need to use the linear interpolation? No, probably not. Okay, so here (1.25%) of interest rate provides 11.079, 11.079, which is very close to this value, right? So I would say the approximately 1.25% is a monthly interest rate. Okay, so how do you compute the nominal annual interest rate? Nominal annual interest rate. How do you compute it? Because there are 12 months in a year, you just need to multiply by 12. Okay, 1.25% multiplied by 12. So how much is this? That is going to be 15%. So this is the answer for problem 7-3. What about, okay, we can solve 7-5. Helen is buying a $12,375 car with a $3,000 down payment, followed by 36 monthly payments of $325 each. The down payment is paid immediately, and the monthly payments are due at the end of each month. What nominal annual interest rate is Helen paying? What effective interest rate? Okay, so these problems are also very similar to what we have solved from the previous chapters. Only the difference is we are using different technique, which is called rate of return analysis technique, rather than present worth or the annual cash flow analysis. Okay, so we are solving problem number 7-5. Okay, so first let's draw the cash flow diagram. the price of car is $12,375. And how much she down paid? $3,000, right? Immediately. And then for the next 36 months, she need to pay $325 for the next 36 months. Okay. So this problem is very similar to the previous one, problem 7-3. Okay. So again, because the internal rate of return is the interest rate that makes both present worth and the equivalent uniform annual worth equals 0. Here, 12,375 minus 3,000 equals $325. Then you need to convert this to equivalent present sum of money. So P given A, I percent over 36 months, right? So you need to solve this equation. So P given A, I percent over 36 period is equal to 12,375 minus 3,000 divided by 325. So how much is that? Okay. This is the $28,846. So you need to find the interest rate that matches this number. Okay. Over 36 period, P given A, so from the compounded interest table, it is approximately, again, 1.25%. Okay, that provides $28,847. $847. So only $1 is different. Okay. So this is the monthly interest rate. Now, how do you compute the nominal interest rate, nominal annual interest rate? Again, you need to multiply by 12 because there are 12 months in a year, which is 15%. Is that the same? Okay. In problem 7-3, you also have %15 as the nominal annual interest rate. And now, how do you compute effective interest rate? So you need to use the formula 1 plus 0.0125 to the power 12 minus 1. Okay? So how much is this? Okay. This is the 16.08%. So that is the effective interest rate. That's the problem 7-5. Now let's solve okay, how about 7-6? Okay. Peter bought an island from an Indian in 1626 for $24 worth of glass beads and trinkets. The 1991 estimates of the value of land on this island was $12 billion. What rate of return would the Indians have received if they had retained title to the island rather than selling it for $24? So Peter bought an island from the Indian in 1626 for $24 worth of glass beads and trinkets. Okay. So we need to solve an equation. Okay, first let me write down the problem number we are solving, which is problem 7-6. Okay, so let me reread the problem description again. Okay, so Peter bought an island from the Indians in 1626 for $24 worth of glass beads and trinkets. The 1991 estimate of the value of land on this island was $12 billion. Wow. Okay. What rate of return would the Indians have received if they had retained title to the island rather than selling it for $24? Okay, so we need to solve equations. So $12 billion. So we have 9 zeros, right? $12 billion is equal to $24. But you need to convert this to the equivalent future sum of money. So you need to multiply by F given P I % over N periods. Okay? So what is the interest period here? N. 1991 minus 1626. How much is this? How many years a day? Is 365, right? 365 years. So we're going to use n equals 365. Okay. So 12 billion equals 24 f given p I percent over 365 years. Or this is same as 24 times 1 plus I to the power 365, right? With other expression. So here 1 plus I to the power 365 is equal to 12 billion divided by 24. So how much is that? This is 500 million. Okay. Then how much is that? Oh. So this can be solved on most hand calculators. I would be 5.64%. Okay. Alternatively, you may want to use linear interpolation technique to find I value here. Okay. So here okay, well, I'm going to stop here for today, and next time I'm going to continue to solve end of chapter 7 problems. So we have 1, 2, 3, probably 4 more. And so just to let you know, after we talked about chapter 7, after we solve end of chapter 7 problems, probably either we're going to talk about chapter 8 or chapter 9. And because we don't have enough time, probably we are going to talk about a little bit about the future worst analysis in chapter 9, or incremental analysis in chapter 8. Anyway, let me think about it, which would be more appropriate for you. Okay. Okay. So after chapter 7, we'll be talking about either the incremental analysis a little bit more in chapter 8 or future worst analysis in chapter 9. Okay? But at this time, I'm not quite sure which one I'm going to talk about later. Okay, anyway, this is all for today, and I will see you next time. Thank you. Bye-bye.